Hello everyone and welcome to another video with Mr. Math. Today we're solving the definite integral from 0 to 2 of the absolute value of x squared minus 9 dx. So the first thing that we need to do here is to reshape our integral because we have an absolute value which will have a positive and a negative behavior. Okay, what we need to remember is the definition of our absolute value, which is the absolute value of a variable x could be positive if our x is greater or equals than 0, or is negative when our x is less than 0. Okay, so we need to take this definition and mirror into the expression. We have absolute value of x squared minus 9, and this has to be equals to what? To the positive behavior x squared minus 9 if, right, x squared minus 9 is greater or equals than 0, and will be a negative behavior, which will be negative x squared plus 9, that we can write actually 9 minus x squared will be easier, if x squared minus 9 is less than 0. So let's pay attention to something here. This expression on yellow is x squared minus 9 greater or equals than 0. So the expression below x squared minus 9 less than 0 is just the denial of the expression above. So if we solve x squared minus 9 greater or equals than 0, we will have the other one just by denying the solution of that one. Okay, so let's solve that. How do we solve x squared minus 9 greater or equals than 0? What we need to do is to factor, in this case, a difference of squares, x minus 3 times x plus 3 greater or equals than 0. Find the critical points that on this case will be x equals to 3 and x equals to negative 3. I like to create a small table here, very simple, with the line number on top. I have negative 3, I have my positive 3 there. Okay, I have x plus 3, and I have the polynomial of x, which will be the multiplication of both, right? So this is continuous because it could be greater or equal to. So the value that will make 0 this initial expression here is the value of 3. So to the right of 3 we'll have positive values, to the left we'll have negative values. Now the value that will make 0 this expression is negative 3. To the right of the 0 we'll have positive values, to the left we'll have negative values. Okay, so what can we say? We say negative times negative, that becomes positive. Now this negative times this positive becomes negative, and at the end this positive times this positive becomes just positive because it's greater than or equal, so we know that the answer will be here. Okay, perfect. And so let's just take this one to our problem here. This means that is x squared minus 9 in what interval? From negative infinity to negative 3 union 3 to positive infinity. On this case, I'm going to amend something here because those should be close intervals. Okay, because it does include the 3. How do we know it does include? Because it's greater than or equals to. Okay, for the negative behavior 9 minus x squared, the only difference that we'll have here is the denial of this. So the denial of this will be from negative 3 to 3. Okay, so that being said, our interval, our main interval, our limits of integration here are going from 0 to 4, right? If those are going from 0 to 4, what do we know? We know that from -3 to 3 should be the negative behavior, right? So in this part here should be a negative behavior. And from 3 to 4, which is landing here, which is the 3 to positive infinity, that should be a positive behavior. Okay, we need to reshape our integral, and then we'll solve from there. Let's shrink this for a second so we have more space. Okay, so if we reshape our integral, this will say something like the integral from 0 to 3 of the negative version, the negative behavior, 9 minus x squared dx plus the integral from 3 to 4 of the positive behavior, x squared minus 9 dx. Okay, let's go ahead and solve each one of this. For the first one, we'll have 9x minus x cubed over 3, and this will be evaluated from 0 to 3, plus this will be x cubed over 3 minus 9x, and this one is evaluated from 3 to 4. Okay, the first one will be the function evaluated on 3, so it will be 9 times 3 minus 3 to the cube over 3 minus the function evaluated on 0. Once again, we know that this one has the variable, this one has the variable, therefore if I evaluate on 0, that will just disappear, so we don't need to calculate in 0. And this will be plus, now the function evaluated on 4, this will be 4 to the cube over 3 minus 9 times 4. Let's place this in parentheses so it's easier to understand. Minus the same but evaluated on 3. Let's move this a little bit more to the right. Okay, so we'll have 3 to the cube over 3 minus 9 times 3. Okay, so the first one will be 27 minus 3 times 3 is 9 times 3 is 27, and 27 divided by 3 is 9, plus 4 times 4 is 16, and 16 times 4 is 64 over 3 minus 36. Remember that this will be minus 3 times 3 is 9. 9 times 3 is 27 divided by 3, there should be 9 only, minus 9 times 3 is 27. Okay, 27 minus 9, that should be 18, plus I'm gonna leave this open here so we have a better answer at the end, 64 over 3. We don't want to work with decimals, we have to do it as we have to avoid it as much as possible. Minus 36, and 9 minus 27, that is equals to negative 18, because I have a negative out, that will be positive 18. And I don't know if you can see it, but this is taking a easy shape here. So if I put it all together, I just need to erase this parenthesis because there's a plus sign, so it really doesn't change anything. So what I have here, I have 18 plus 18, that's 36, minus 36. That will cancel out, and my answer is just 64 over 3. All right, thank you for watching. Remember to send your questions, send whatever you need to know. Remember to follow us on social media. We will be happy to help. We hope this video was helpful for you. Thank you.